was instead of an 11, I threw in a 100. Okay. So, what is the median? It's still 9, right? That 100 did not affect the median at all. What's the mode? So 7 plus 8 plus 9 plus 10.
There is no mode.
What is it? I mean, not the mode. I'm sorry.
The mean?
The mean. Thank you. The mean. What's the mean? I think you said it earlier. 26.8. Over here, do you think 9 is an accurate reflection of the center of this data? Yeah.
Yes.
Yeah, 9, because 7, 8, 9, think of them, the dots on a number line, they're all close together. The weight is where they're close together. Same thing here. Do you think 9 is an accurate reflection of this weight? No, it actually is. It's a better reflection than that. Is the 26.8 an accurate reflection of what's going on? No. What did that 100 do to the values? It pulled it all the way to the right. It shifted its weight. Again, think of it like a number line, right? You have 7, 8, 9, 10, and then 100 over here. Think of it as, you know those tilting scales like this? You know what I'm talking about? Okay, that you have all your dots, and then one's way over here. What happens to the weight? It pulls it this way, right? It shifts it all the way that way. So that's what this 26.8 is doing. Here's 7, 8, 9. Well, this 100 is pulling it that way. It's shifting the weight that way. Okay, so this 100, we actually have a term for it. It's called an outlier.
What?
An outlier. O-U-T-L-I-E-R. Outlier. If there is an outlier, you do not want to use the mean. Do not want to find the average. Go back to my test values. I have most of the class making C's, and 3 people did zeros. Those are outliers, right? They will mess up your average. So if there's an outlier, you want to avoid the mean. Okay, that's our first hint as to which is the best description. So what we'll say is the median is resistant to outliers. You know what the word resistant means? It's not going to be affected. It's resistant to being affected. So the median, notice the median was not affected when I threw that 100 in. I can have an outlier and my median's not going to change, right? From one outlier. That's not going to shift it. We never want to use the mean, the average, when there are outliers. Never use the mean when there. Okay, and then the third one is do not use the mode if it doesn't fall in the middle. I'll give you an example of that. I.e., let's look at these data values. Okay, so if I'm looking at these data values, 0, 0, 0, 1, 2, 3, 4, 5, 6. Okay, think of them on a number line. Where does your weight fall? Around here, right?
4, 5, 6.
Right, around here. This is the center. The mode is 0. Is 0 an accurate reflection of what's going on? No. Even though it occurred 3 times, I wouldn't use the mode to describe this set of data. Okay? Think of it like this is the number of times each student took a quiz. I had 3 that did 0, 0, 0. One person did once. One person did twice. One person did 3, 4, 5, 6. What's an accurate reflection of what my students are doing? Is it 0? Because that's the mode. No, I had way more people doing stuff. Yeah? You'll kind of understand that? So you don't want to use the mode if it's not in the 0. Now if I had 0, 1, 2, 2, 2, 3, 4, 5, then I could say, all right, it looks like most people are doing it about 2 times because the 2's in the middle. Good? Okay. All right, we're going to look at the word distribution. The distribution is how the data falls like number values, the 1s, the 2s, the 3s, right? How the data falls around the median. Around the true center. So when I say median, I'm talking about the true center value. I have 5 on that side, 5 on that side. If the mean, the average, or the weight, is to the left of the median, we call that skewed left. So you'll hear the word skewed. So if something is skewed, then that means the weight is falling to the left. When you squint your eyes, most of those little dots are to the left. If the mean is, or the weight is to the right, it's skewed right. Okay, so if we say that, for example, this is not really example, so let's just do an example. Let's say the mean salary for a job. Does everybody understand that? I hate mean salaries. If you ever look up the educational mean salary, they'll be like, oh, teachers make on average $50,000 a year. No, they don't. It's the principals and the administration that's making like 80 to 90 that's skewing the average over to their side, right? That in education on all levels, it works like that. It drives me nuts. They'll do the same thing with companies. They'll say, oh, the average salary for this company is $70,000. No. The average is more like 50 for the people, but the corporate level's making hundreds and whatever, so it's skewing the average up. And they do that all the time with data values. So this is why you take this course and you take this class, so you can be aware of what people, the numbers that people throw at you, and just take them with a grain of salt, because people like to tweak numbers to make it look beneficial, and you can do that. All right, so let's say the mean salary is $80,000. The median, that's the very center value. So I line up all the salaries for this company, right? This one makes 20, this one makes 25, this one makes 50, this one makes, and line them all up. The very center value is $63,000. The mean, okay, so if you look on a number line, right? The median is here at 63. The mean is here at 80. This is a skewed right set of data values, because the mean falls to the right of the median. The average is falling to the right side of the median, the very center value. So we say that that data is skewed right. Okay? Does that make sense? All right. All right. Next set of info, we're going to talk about what's called number summary. Everybody knows hashtag means number, right? Yeah. Okay. It's the new thing, right? Okay, summary.
Or pound.
It does mean pound as well,
Yeah.
but that's like throwback way.
I know.
All right, so the 5-number summary. Okay, so what we're gonna do is we're gonna take the data values, right? Just write this down and then I'll explain everything. You write down exactly what I have. I will explain everything, I promise, okay?
Is that like a percent sign?
Yes.
Okay. Yeah.
Okay, I'll give y'all a minute to copy that down, then I'll explain. Copy? Okay, so this is called a 5-number summary, and the reason it's called 5 numbers is because there are 5 numbers that we're going to have. This one right here is our actual minimum value, so we have a set of data, 0, 1, 2, 3, 4, 5, 6, 7, 8, right? A bunch of numbers. The very smallest is called the minimum value. The very largest is called the maximum. Does that throw anybody off? Okay, good. Phew. All right, this one right here is the median. It's the dead center. So whatever the median is, this line bar right here is going to represent that median. Okay. This value right here is the median. It's the dead center between the minimum and the median. Okay. I'm going to do an example to apply this, by the way. Okay. So you have a minimum and a median. The center of those goes here, and that's the median of the lower half. We call that Q1 or quartile 1. Quartile is the word that's quartile 1. So this value is the median between those two. Over here, this is the median of the upper half, right? The upper half of data, the dead center. We call that quartile 3. Okay, why am I not calling it quartile 2? Because this is considered quartile 1, this is considered quartile 2, quartile 3, quartile 4. Okay, so the quartiles, or you have 4, even though it's a 5-number summary, you have 5 numbers, but you have 4 blocks, right? 1, 2, 3, 4. It just so happens that when we look at the data like this, the data that falls between the minimum and the Q1 represents 25% of your data. So 25% of your data is going to fall in this first quartile. 25% of your data is going to fall in the second quartile, 25% the third quartile, 25% in the fourth quartile, right? Okay, the IQR is the inner quartile range. So to find the range of something, you subtract the high minus the low. Okay, so the range of something, maybe I should put that up here, huh? The word range is the high minus the low. So the interquartile range would be Q3, quartile 3 minus quartile 1. And that's your interquartile range. Are we good so far? Okay. So let's look at an example. This would be our official example 2. What we're going to do is look at the vacation days that are reported for various countries. How many vacation days do different countries report? Okay, so vacation days, VACATION. Isn't that weird how it does that? Just changes on its own. Days reported. All right. We have Italy, and it reported 40. France, 37. Germany, 35. I'm moving to Italy, by the way. As soon as I can convince my family to come with me. Brazil, 33.
Why? To make 40 vacation?
Yeah. That's a low-stress country right there. Britain, 27. And I love Italian. Cheese, olives. Canada, 26. Pasta. I'm going to have pasta. Live on pasta.
How you say
Japan.
so small live on pasta?
Huh? Because I have 4 kids and I'm choosing not to pasta. Long time to eat. US 50.
You feed your kids instead of yourself.
Mom, you forgot to feed us. Oh, did I? Go get some cereal milk. All right. So here are our data values. Let's go ahead and do a 5-number summary. What is the minimum value?
25.
15.
The minimum?
Oh, minimum, yeah.
Yeah.
15.
Oh, I thought you said 50. Sorry.
Oh, it's okay. Yeah, no.
I didn't
US
look.
We worked on this. All right. So US is 15, or the minimum. What's the maximum? 40. Okay, I think they're in numerical order. So you got 40, 37, 35, 33, 27, 26, 25, 15. Okay, so they are in order. What is the median?
20, 30, 30. No, 27.
25? No, 30.
Well, let's see.
Oh, but
Okay.
they're not in order.
Look, you have 40, 15, right? 37, 25. 35, 26. All right, so we have 33 and 27 are the 2 middle values, right? So we're in numerical order, and we come down to this, 33 and 27. How do you find the center of those 2 values? Any ideas?
You
You average them, right? So we're going to do 33 plus 27 divided by 2. We're gonna do 30. All right. Now, 15 and 30, what is the median between 15 and 30? Okay, so look, let me do it like this. Watch. We have
7 point. No, never mind.
15, 25, 26, 27, 33, 35, 37, and 40. Okay, so we said the median is here, right? This is our min, that's our max. What is the median value between here?
27?
I would call that
Oh.
25.5.
Yes. Yep.
Everybody see that? You sure? The median of the lower half. Yes?
Mhm.
Okay. So my median here, I'm going to go ahead and put 25.5. All right, what about the upper half?
36.
36. Very good. Okay, so minimum, right? Minimum, Q1, median, Q3, maximum. Okay. So just looking at this that is the 5-number summary. Okay, so you're done. So just looking at this, what percentage of countries reported took between 15 and 30 vacation days? What percent of countries reported took between 15 and 30 vacation days? What percent?
Did you add all that up?
No. What
50?
percent? 50%. Well, how much of the data is falling in this range?
25.
25%. How much is falling in this range? 25%. So what percentage took between 30 and 15? 50%, right? What percentage took between 36 and 15? 75. All right. So I can ask you questions. Once you have this 5-number summary here, I can start asking you questions about the percentage of people reporting. Yes? Okay. Are we good? Moving on. All right. All right. So next thing, let's talk more about outliers. Outliers. Ooh, that's wrong. Will be present if 1.5 times the interquartile range falls outside the minimum or the maximum. I will explain. Outliers will be present. Okay, so we're talking about outliers. There's one or two set of data values that screw up everything, right? They completely take your weight and shift it over. In the case of that 100, that one data value of 100 completely took my weight and shifted it dramatically, right, to the 26.8. All right, so let's say that we have a 5-number summary that is 15, 25.5, 30, 36, and 40. The interquartile range, IQR, is 36 minus 25.5, which is what?
11.5? No? I'm not using a calculator.
10.5?
It might be. I didn't use a calculator.
Yeah, the 0.5 stuff me off. I have 10.5 in my notebook. Since this is my third
That's right.
semester and nobody corrected me, then we'll go with it, right?
Yes.
But I have had crap in my notebook for many, many semesters, and then all of a sudden one semester's like, that's not right. Okay, I've been doing this for 5 years and nobody ever said anything. All right, so it's 10.5. So this is your IQR, right? So we will know we have it out there if we do 1.5 times 10.5, and we should get 15.75. Everybody's with me so far? This is kind of confusing. Everybody's good? Mm-hmm. Okay, so what you want to do is look at Q1. Q1 is 25.5, right? Q1 minus 15.75, 25.5 minus 15.75 equals what? I don't have that written, so if you guys don't mind giving me that number, I guess I could write it, huh? For the future. 9.75. Okay, it's 9.75. This number falls outside of my
thing.
correct. Thank you.
5 numbers.
Thank you. Which means, okay, so because the 975 is over here, right? 15 is within it, so we do not have an outlier. Whew. Do y'all understand what I'm saying? I always struggle with this problem. Okay, look at the Q3. Q3 minus 15.75 equals what? Plus 36 plus 15.75 is 51.75.
How you know to add that one in?
Because because what I want to do is take this number right here, and I want to say what is 15.75 that way, and what is 15.75 that way, according to number line. Okay, so if I want to go backwards, I would subtract 15.75. If I want to go forward, I would add. So this way, I go plus 15.75. Here, I go minus 15.75.
What Q3? What was it? What is the number of Q3?
This one.
Oh, okay.
36.
Okay.
So 36 plus, this is 36. Q3 is right here. Plus 15.75 is 50, and I did that in my head. So if y'all want to check that, you can. So do you see how 40 falls within? It falls on the inside of these two values that I found. Okay, there are no outliers present in this data. So we say no outliers here. Let me show you one where there is outliers, okay, so you can kind of see the difference. All right, so here we go. 738 is our minimum. 774 is Q1. 855 is our median. 1,097 is Q3. And 170,000 is our max. Okay? So we want to take the interquartile range, IQR, which is what? How do you find the interquartile range? The word range means high minus low.
That minus that.
Yes. High minus low. So what is it?
297.
I'm getting 323. Is that what you guys got? Check me out. What I have written.
Yeah.
Okay. Once you find the IQR, am I going too fast? No. Okay. Once I find the IQR, I'm going to take 1.5 and times it by the IQR and get a number. 1.5 times 323, I'm getting 484.5. 484.5.
Yes.
Okay, I'm going to take that number. From here, I want to add it. And from here, I want to subtract it. So what is 774 minus 484.5?
289.5.
289.5?
Mm-hmm.
Okay, 289.5 is 738 within 289.5 and 774. On a number line, if I have 289 reported is the number 738 between 289 and 774? Yes, so this is not an outlier. Our minimum is not an outlier because the number 738 is between 289.5 and 774. Okay, let's look at this value. What is 1097 plus 484.5?
Around 1500. I mean, yeah, 1500-ish around.
I read it.
1581.5.
1581.5. Is the number 170 between 1581 and 1097? Is the number 100? Think of a number line. No, it's on the outside. Y'all with me? This is an outlier. Because on a number line, 1097, then I would have 1581, then I would have 170. That one. Right? It is on the outside. It does not fall within 1.5 of the IQR. Okay? That is considered an outlier. Yes? Okay. Whew. I hate that problem. It's for whatever reason, I struggle explaining that. Y'all okay with it? Okay. All right. The last thing we want to talk about is weighted averages. I know, right?
Feels like Monday.
Is that Monday? All right. So we're going to do 2 examples of weighted averages if we have time. Okay, let's, example 1, 2, is this 3? Example 3?
I don't even know.
All right, let's say that your midterm is worth 15% of your grade. You have a class project worth 20% of your grade. You have homework, which is 50% of your grade. You have an exam, which is 15% of your grade. Okay, so you have 100% of your grade is found this way. Let's say that you made a 60 on your midterm, an 88 on your class project, a 90 in your homework, and a 72 in your overall score on your exam. Okay. So this is considered a weighted average because even though you have 4 grades, they're each worth a certain amount towards your final. Okay, so they're not equal. You don't take the 60, the 88, the 90, the 72, add them up and divide by 4. That would be an equal weighted average. Each number is weighted in a different percent. So the way that we do this is we're going to take 15% of 60. So to do that mathematically, we do 0.15 times 60 plus, and then we're going to do 20% of 88 plus 0.5, 50% of 90 plus 0.15, 15% of 72. So, here on 0.15 times 60, 2,
82.4.
so your class average is 82.3. Yes? Weighted averages. So this course, it does have weighted averages, right? Your homework is 10%, your quizzes are 10%, your tests are combined 50%, your exam is 20%. Your attendance and participation is 10%. So if you ever want to figure out your grade, this is how you do it. It's your weighted average. All right, one more weighted average example, and then we can go. Whew, we used the whole thing, huh? Example 4. Your GPA, okay, and I'm not going to write all this down, but everybody in this class has a GPA, and the way that it's calculated is if you have an A, you earn 4 points per credit hour, okay? So each course you take is weighted a different credit hour. It depends on how the course is designed. This course, Finite Math, is a 3 credit hour course. Yes? You do take some classes that are like a lot of your labs are only 1 credit hour. Sometimes you'll take courses that are 5 credit hours. So the credit hour is dependent on the course. If you get an A, you get 4 points per credit hour. If you get a B, you get 3 points per credit hour. A C is 2 points per credit hour, and a D is 1 point per credit hour. An F is 0 points. Okay, and that's how your GPA is calculated. So as you progress in college, your GPA will go up in a smaller amount, because once you have a ton of credit hours, your freshman, sophomore, junior year, your senior year, you're only adding a few credit hours, and you already have the bulk of your GPA settled. Do y'all understand? So your growth rate is going to be smaller the more credit hours you take. Yes? All right. So let's say we want to find the GPA of this student. They got an A in a 3 credit course. A B in each of 2 credit courses. A C in a 3 credit course. A D in a 2 credit course. Don't want to get a bad grade in a 5 credit course. Right? Okay, so here we have a 3 credit. Let's do like this. We have our credit. How about our grade? And then we'll do our number value. We'll make like a little chart, okay? So we got an A in a 3 credit course. So that gives me how many points?
3,
12.
4. Oh,
Because
4,
an A is
yeah.
worth 4 points. So 4 times 3 gives me 12 points. I have a B in 2, so I got a B twice in 2 credit courses. Right? So how many points did I get from this course right here? 6, 3. Oh, I said 6 and I wrote 3. 3 times 2 is 6, and then in this class I got 3 times 2, which is also 6. Right? Okay, then I got a C in a 3 credit course. How many points did I get?
2.
2 times 3 is
6.
6. And then finally, I got a D in a 2 credit course. So how many points did I get? I got 2 points. Yes? Okay, so how many credit points did I earn? How many? I got 32.
32.
Want to recalculate? 12 is 24. Plus 8, 32? Okay, 32. How many credits did I take?
12.
12. Your GPA is the points you earned divided by the credit total you took. Points earned divided by the total credit number. What is this student's GPA? We'll round to the nearest 10th. I'm getting 2.6 repeating. So rounded to the nearest 10th would be a 2.7 GPA. We're good? Okay. All right, so that's how you do the GPAs. All right, that's all I have for you. Let me put your homework. All right, let's see here.